Hi, welcome to the closeout video on CEMScript project. My name is Ilia Rodionov and I'm a delivery manager at MLabs. While developing applications on Cardano, we tend to repeat ourselves many times. More or less the same things appear again and again, first in on-chain scripts, then in off-chain code, then in testing suites, then in indexing stuff, and so on and so forth. So, CEMScript is an attempt to rethink how we do define our applications. So instead of building all those components from scratch, you define a state machine, states and transitions, using a specific DSL. Later, all those components can be automatically generated out of that description. Let's take a look. Let's take a look at the auction example to get an idea what such a description of an application might look like. Here, first of all, we introduce a data type to represent the bid itself and a tag to tie together all components of that application. Then we define in which states our application might be. So we say that it can be not started, it can be in the progress, and that this bid argument represents the outstanding bid, the biggest bid, and it can be in winner state, where this bid represents the winner of the auction. Then we define a data type to represent parameters for application. Of course, every auction is different and is specified by the seller and a particular lot. Then we define different types of transition. These transition tie together different states, but here we don't say which exactly. This is done in a separate definition. The core part of the CEM application is CEMScript instance, which is defined here, and an additional CEMScript types instance, where we say what our types are, basically what are parameters, what are the application state, and what are transitions. So in CEMScript, the most important component is transition spec definition, which basically defines a map. For every transition we say what our constraints, so what conditions should be held in order that transition to be valid. So for example, we can see, so for create spine, spine is a technical detail which just preserves only the name of the constructor, omitting all the content of data types. We require that something should be spent by the seller, effectively mean loveless value should be spent, and there should be an output that goes to the CEMScript, the script that represents that application, with a particular state in the data and with a particular value. And in that way we define all other transitions. You can find more information about how it's done for this example in the documentation or in the article on MLabs website. From that definition, CEMScript can generate automatically a Plutarch-based on-chain script for your application, an off-chain part for building and submitting transactions, a configuration for indexer, and a helper function to restore the application state out of encoded data, and a state diagram for your application. To see how it works, we can run a test suite. Test suite contains different types of tests. First of all, we can see that the on-chain script for our application is compiled and is roughly 9,500 bytes. Then we can see that some unit tests are passing. And finally, we will see that test suite will run a pretty complicated model-based mutation testing to verify that all parts of the applications are aligned. You can find more about our approach for testing in the article mentioned and in the documentation. Thank you for watching.